rock doctor from the Australian National University. So I'm basically a rock star. Except my groupies are all old, crumbly, and quite extinct. I'm obsessed with rocks. And you might think, oh, geologist alert. Although maybe not in this room. There's a lot of GA people here. Yawn. No. I'm a paleontologist. I dig fossils so cool, they make Indiana Jones ditch his whip for a microscope. But let's be real. If Indiana Jones was a paleontologist like me, and his movies would be so short because who needs treasure when you've got microscopic masterpieces? So recently I birthed a tiny human, as you can hear. Thank you. So obviously my fossils I'm now a micropaleontologist, and my fossils are about as small as her patience for naps, which is about the width of your hair. So here I've got photographed my hair with the little fossils I found in the Indian Ocean. And we find these all around the world. I also manage the Australian and New Zealand branch of the IODP, which is the International Ocean Discovery Program, the world's oldest deep sea geoscience program. It's actually 1 month older than NASA, but a lot less known than, say, Belconen's infamous Bell and Al. So what IODP does, we get these big ships, that's about 143 meters, and we drill deep below the ocean, kilometers deep, to get rock samples. Here's a photo of me after we've just pulled up one of those rock cores from the deep sea. And yes, that's me trying to pull the whole core into my lab and everyone else playing tug-of-war, saying they can't get it. So once I get my samples, finally, I look at them under the microscope and I hunt for them. And it's like playing a high-stakes version of Where's Wally with extinct tiny plankton, except Wally's been dead for 500 million years. He's also made of glass. It's actually thrilling stuff. Actually, a lot of people, when they finally hear that I am a micropaleontologist studying deep sea fossils, they often thrust their weird beach rocks at me. Spoiler, they're just rocks. Actually, the madness hit peak absurdity recently when my grandfather passed down his cherished yet monstrous, like huge, uncurated rock collection. Forget gold bars. My inheritance was a rock avalanche under the family house. Don't get me wrong, it felt like Christmas going through it all. The problem is I'm crammed into a tiny Canberra apartment with a baby and a coffee maker where I can barely find a space, and I also have a rock avalanche. So I barely sail these days. Maybe I'm out there 10% of my time. Most of my time I'm writing or I'm editing. So I'm playing rock, paper, scissors most of my time. Thank you. If I could, I would choose rock every time. But I would lose. So my job, I date disasters, romance not included. And by finding a date of when these fossils kick the bucket, it helps me build a timeline of Earth's past natural disasters, either volcanoes, earthquakes, tsunamis, or climate change. And speaking of disasters, actually, today's my 4-year wedding anniversary. And I'm here cracking jokes instead of cracking a bottle with a man outside the door with a baby. He knows that date night's probably a night spent in the lab, carbon dating a little microfossil, or digging up past disasters. So I want to know how fast, how often are events related, and how long do we have to prepare? That's what I'm doing with my little fossils. And this is actually my favorite fossil I found. It's really pretty. And to date this, I sometimes need to break them, which, please don't tell my boss. His wife's in the back there. I need to break them so I can examine the internal structures and identify new species, work out when they perished. And to do this, I get a microscope and a really small pin. And I use a technique, a highly advanced scientific technique, unpublished, that I call caffeine-fueled percussion. This is a true story. It took me 2 years to build the courage to break. So I chugged a bucket of coffee till I got that rhythmic shake. And under the microscope, I just moved my hand till I surgically cracked a 10-micron shell. Thank you. Yeah, this broke perfectly. I was actually expecting multiple shells, but instead there was this beautiful chandelier-like structure. And we find these fossils from sailing all around the world. And when we finally bring them up, I get so excited because it feels like Christmas again. And I get to add another rock to my avalanche at home. Very acceptable decor. So let's talk about my fossils more. They're called radiolarians. They're single-celled plankton with glass skeletons that make snowflakes look lazy. And again, they're littered all across the ocean. I'll let it play out. So this is a map of the world where radiolarians are the dominant deposit on the seafloor. So that green area. So you can see they're very significant. And unlike the Kardashians, I call my fossils the original influences. Because they have been shaping the ocean story for millions of years. It's because they have glassy skeletons, they can survive eons, unlike the Kardashians. But like the Kardashians, my radiolarians are like cockroaches. But of the plankton world and much more aesthetically beautiful. So, thank you for that snort. So just going to an example. So we recently, not celebrated, we recently reflected on the 2004 Boxing Day tsunami. This was a 9.2 magnitude earthquake that caused a giant tsunami, 30-meter high waves, and killed 250,000 people. When that happened, it defied all our models at the time. It should never have been that big. So, in 2016, I jumped on a boat and we sailed out there to get the sediment recipe to figure out why it slipped so prolifically. Here's a photo of me on the ship, taking a little sample. Also a photo of me, someone caught stealing someone else's jacket. Yeah, I was the radiolarian expert on board. I was hunched over a microscope the whole time while the ship rocked. I was seasick constantly, hurling for science 24/7 for 2 months straight. Worth it. We hit the jackpot. Great weight loss program. So we found this massive biosilica layer under this giant sediment package. And that's where ground zero of that earthquake happened, in that naughty layer. So here's just some cool photos, because there are some geos in the room. So on top, that was sort of what we found, but that middle layer there was that giant sediment package. And that was mostly sand, some coarse and fine grain, all those turbidites. But this was the naughty layer here. So this was packed with radiolarians and a bit of lithified limestone. So, and this is just a little close-up of diagram of what that naughty layer looked like. It had my radiolarians that sort of look like ball bearings and some fine-grained mud. And I don't know if you guys have ever had 1.5 kilometers of sand on top of you. No one? It creates a lot of heat and pressure. And when you do that, you get a chemical reaction happening in my little fossils. The glassy skeletons go from clear to opaque, and water molecule comes off and hydrates that slippery mud. So when that subduction zone snapped, A massive slippery layer lubricated by my tiny influences, not the Kardashians, slid like a greased pig. 1,500 kilometers of ocean floor shifted 15 meters. Here's a quick diagram, not going to go into it too much, of Sumatra just down there. And look at that scale bar, that's 500 kilometers. And up in the ocean along that kind of line with the little triangles, that whole green area, that's how much land slid. This discovery wasn't just a one-off. Take Japan's 2011 earthquake. Magnitude 9.1, another shallow slip, another monster tsunami. We drilled there too, and guess what? Same sediment recipe. But here's the twist. It's not just tectonic zones we've got to worry about. We know that Australia's tectonically stable, but have you heard of climate change-driven tsunamis? You see, sea level rise isn't even across the globe. It's actually falling in some places. What? Here's a map, and you've got Australia there, the Pacific Ocean, North America. Anywhere you see a little beige to a dark brown dot, the sea level's actually falling. Why? So let's take a look closer at Alaska at the top there. So what's happening? When it was colder, there was a bigger ice shelf. It was heavy. When it melted, it got lighter, so the land rebounded. Also, just like the moon with the tides, the sea level also dropped. It used to be attracted to that giant mass on land. And as that rebound happened, this rebound can trigger submarine landslides, big ones, no warning. And that's where I come in. By dating microfossils and analyzing the slippery layer beneath, I'm helping build a predictive map of where the next big one could happen. It's like weather forecasting, but instead of chance of rain, it's a chance your house surfing the Pacific. Spoiler, it's not zero. So just to wrap up, next time, I'm not just a fossil nerd with a coffee shake. I am trying to reduce human suffering by time traveling. And next time you find a beach rock, think of me. Think of me with a baby on my hip, my husband barricading the front door from the Stern invasion, me yelling, but I don't have these rocks. And just my last slide, just a credit to AI for all my slides. It's come a long way since 2012. This is a prompt of female geologists drinking beer on a hot day. Thank you.